Hey there, Sixes. So today I want to introduce first just two ways we can display data, and then we're going to start looking at how do we compare data sets. Like instead of having one set of exam scores here, if I had exam scores and a list, and then exam scores and another list, how could we look at those two and say like which class did better on the exam? Which class, there are lots of interesting questions we could ask comparing two different classes' exam scores. But first, I just want to look at dot plots and stem and leaf plots. And in order to talk about those ways to represent data, we're going to be using this data set. So these are just exam scores. You could think of them like percentages. The best student got a 99, and I think the worst student, oh no, the worst student got a 40 here. And they're just all exam scores. So first, if we're going to make a dot plot, here's the way dot plots work. These are super rudimentary, and we have exam scores, great, we have all these. So when I make my dot plot, I start with a number line, and I need to be able to set up on this number line, like where's going to be the different amounts. So when I look here, our top was 99 and our bottom was 40. So top should be on the right. I'm going to make the top go up to, let's say, 100. And then the bottom would go down to 40. If 42 were the bottom, I still would just go down to 40 because 42 is kind of it's not a nice round number like 40 is. I would stop there. So we'll make that 40. And then in the middle here, we'd have to have 50, 60, 70, 80, 90, 100. So 70 is right in the middle. 70. And then I know I have in the thirds, if I try to be close, 50, 60, 70, pretty good. 80, 90, 100. So 50, 60, 80, 90. So now our number line is set up for a dot plot. And how you finish it is exactly how it sounds like you would finish it. One thing that's strange is oftentimes when we say a dot plot, we use X's to represent the data though. So for 99, I could go ahead and put like a dot at 99, or what's normal is we just put an X near there. And then as things like pile up, they'll stack. So 97 is like a little bit below 99. Then I'm on 40, so 40 is the absolute bottom. At 65 was in here, next one is 80, and you get the idea. I'm just drawing dots to represent where the different data were. 88 is up here, 82 down here, 84. Well, this is starting to get pretty busy in here, so 84 I'm just going to kind of stack up a little bit. And 68 is like in there, 57 down here, and then 42 is like barely above that. So this is the way dot plots work. It's literally just one X or one dot to represent each data point. And you can see approximately where they are because they just kind of stack up to show, like I can see this is the largest collection of data we have, but the rest of our data is kind of spread out. Yeah, it just gives us a visual representation of what that data looks like. A stem and leaf plot looks very different. So stem and leaf looks like this. On the left side of the line, we put the stem, which is the major classification. And on the right side, the leaf, which is the minor classification. In our case, all we have is exam scores. One thing that is common, and I don't know why, I don't really like this type of representation, but we put the tens on the left-hand side, and we put the ones on the right-hand side for the leaf. So when I look here, I'm going to have tens being my stem and ones being my leaf. So it's strange, but I'm going to look through it just for all of the stems that I can find first, or all the different tens that we have. So the tens we've got, I've got 90, I've got 40, 60, 80, 70, and 50. So that's 40, 50, 60, 70, 80, 90. So I'm going to have 40s, or we could, it's common to start at the top and go down. 90s, 80s, 70s, 60s, 50s, and 40s. I want this to be neater, so I'm actually going to use this. We have 90s, 80s, 70s, 60s, 50s, 40s. Great. Then the leaves will be the different scores within the stem that we had. So in line with the 9 here, I want all the 90s. So what are all the 90s we had? There's 99, 97, and that's it for the 90s. So when I go here, come on, I want 97 and 94. Those, good. Why won't it change color to black? Okay, good. In the 80s, then I'm looking for 80s. Here we have 80 and 88, 82, 84. So 80, 82, 84, and 88. It doesn't really matter which order I put them in. 80, 82, 88, or 84, 88. Fine. Then 70s, we've got 72, and that's it. 60s, I've got 65, and I think that's the only one I see. 50s, just 57. Oh, 57. And 40s, we've got 40 and 42. So stem and leaf plots are a little bit strange. If you want to know, like one thing that's nice is I can tell a bunch of students got into the 80s. Like I can really see that the lump of data that happens here and everyone's kind of gathered together. I can really see that in my stem and leaf. But it's a little strange because like the 94 here is splitting up like 94. It's strange. I can see the number of data points, so I can always check myself. Exam scores, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 exam scores. And here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 exam scores. So I missed one. It's 99. No, this should have been 97, 99, 80, 88, 82, 84, 72, 65, and 68. That's the one I missed. Cool. Yeah, so you can see the number of data points over here. I'm probably talking too much. Let's look at your assignment for today. This is what you'll be doing. So we're starting out with dot plots. You guys have an idea now about how the way dot plots work. And we're told one of these is a small car, the other one is an SUV. So SUVs consume more fuel. They use more gasoline than small cars do. Small cars use less gasoline, so they get better mileage. So you can tell which one is which. Tell me and describe why. How do you know? Same type of idea here. Interpreting a dot plot. We've got times for buses leaving certain places. Great. And then we have a stem and leaf. So you should be able to answer some questions about stem and leaf. In here, I'm going to start getting at, there's an idea of average price, or here I ask about the best value in general for DVDs. To use those, you'll have to use some ideas that I hope you've learned in the past, because we haven't talked about averages this year. But you should have ideas of different ways to average, and just know that that's going to be our next steps. That's where we're going next when we compare these. Measures of center or averages will be useful. Good luck, sixes. Go for it. Talk to you soon. Bye.